an ARC linkage grant that is with a co-contribution from Syngenta. We are screening for fungicide resistance in Australian populations. So this involves us having stubble samples sent in from across the country. So we've had 207 samples submitted this year, and then we screen each one of these. So we do that using these tubs. So each one of these tubs is an individual population, and we take the stubble and we use that to inoculate the plants. So I'll just show you what that looks like. So for each of the populations, we have a set of stubble. This stubble is then matured in the field before we bring it in and we wet it up. So you can see all of this looks quite damp. All the fruiting bodies have come up. So these will release the spores. These spores then shower down onto the plants that are underneath, and each of those plants are treated with a different fungicide. So we can then use this method to look at fungicide resistance, and we'll come back in 2 weeks' time and look at how many lesions have developed on each of the different treatments. Okay, so 15 days later, after we do the inoculations, we come back and we score the plants. So what we're looking for is lesion development on each of the different chemistries. So each one of these trays is one stubble population that was in one of those tubs that you saw earlier in the video. And each half punnet represents a different chemistry. So we're going to go through and look at what lesions develop, and that's what gives us an indication of our fungicide resistance. So I'll show you one of these up close. Each half punnet here, so you've got one half punnet, has 4 plants in it, and each one of these is treated with a different fungicide. So here, these 4 plants here are what we call our untreated control, so they've got no fungicide. And you can see there's lots of lesions there that are developing, and actually some of these plants are completely collapsing under here from the disease pressure. We then have an example of an effective fungicide here. So this is our Soltro, which is an SDHI fungicide, and you can see even when it's right beside your untreated control, you've got no disease whatsoever. So all of the cotyledons are completely clean, green and healthy. So we've got no resistance to these SDHI fungicides. We then come to our DMI fungicides. So for example here, these 4 plants here are an example of our flutriafol, which is the fertilizer amended fungicide. And you can see you've got colonisation going on here. The petiole is actually collapsing. Here's another lesion here. This plant under here is also completely colonised. So you're seeing fungicide resistance in this example. Here again, another DMI. This is our jockey, so our fluquinconazole. You can see that the petiole here is completely collapsed. This plant, actually the hypercotyl right down the bottom there, is also colonised. And here again the petiole. So you can see there's quite a big difference between this resistant population here and not having any resistance to the SDHIs. The good news is that this fungicide resistance to the DMIs we're finding is only in about 20 to 25% of the populations. It's not widespread, and we've got no resistance whatsoever to the SDHIs or the strobilurons. It's good news for growers, and we are doing our best to keep monitoring this and see what happens in the long term. Okay, so what does all this mean for growers? So we're seeing that around 20 to 25% of our populations have resistance to the DMI fungicides, particularly the fluquinconazole and the flutriafol. It is much lower for Prosaro. It's only around 7%. But what does it mean in terms of field failure? Are these fungicides still effective? Things like that. So what we don't know at the moment is the frequency of resistance within a population. So for example, the population I just showed you, we know there's resistance there. Are those isolates in 1% of the population, or do they make up 20% of the population? We have no idea yet. The good news is we've just identified some of the genes that are involved in this fungicide resistance, so we can now start looking at that and working out what the frequency is and how that's changing over time. The other thing we're trying to do is work out if we've got this fungicide resistance, are we seeing yield losses due to these isolates? So trying to work out what it means for growers in terms of using these fungicides. Can they still use them and not see much impact, or is it having big impacts in terms of disease control and therefore yield? So those are the things we're doing moving forward, and so hopefully over the next couple of years we'll be able to give you more information regarding on-field application of this fungicide resistance.